So students, last class we did the classification of acids and bases. We did it on the basis of strength, on the basis of dilution, on the basis of what you can say the nature, on the basis of the source. We have done it. Today we are going to do the basicity of an acid and the acidity of a base. What I said? Basicity of an acid. First we will do basicity of an acid. I am saying the definition, you please write it down. What is the basicity of an acid? So remember that for acids we say basicity and for bases we say acidity. It is just opposite. So basicity is the number of hydrogen ions, the number of hydrogen ions or number of hydronium ions replaced per molecule of an acid in aqueous solution is known as the basicity of an acid. The number of hydrogen ions or the number of hydronium ions, that is H plus ions or H3O plus ions, which is replaced or which is being produced. Got it? So in aqueous solution, per molecule of an acid or per mole of an acid, we can say, that is known as the basicity of an acid. So for that purpose, let me give an example like HCl. It is giving H plus plus Cl minus, as you can see. So how many H plus? 1. So it is said to be as monobasic acid. It is said to be as monobasic acid. Similarly, if I say H2SO4, it will give you what is that? 2H plus plus SO4 2 minus. It is dibasic acid because 2H plus ion. So don't count it in this way. Here 2, so here 2, here 1, so here 1. No, not at all. Got it? Now see here, CH3COH. What do you say? 4? No, not at all. You will be getting CH3COO minus plus H plus. So what I said with the definition? Number of hydrogen ions or hydronium ions. Alright, when it reacts with water, this will react with water, but it will give you H3O plus. Produced per molecule of an acid, or the number of hydrogen ions or hydronium ions replaced per molecule of an acid or per mole of an acid is known as the basicity. Here the basicity is how much? Again it is 1. So don't count the atoms, count the number of ions. So in this way we can have monobasic acid, we can have dibasic acid, we can have tribasic acid. Like H3PO4 will give you 3H plus and PO4 3 minus, tribasic acid. Alright. So similarly, this is the basicity of an acid. Similarly, we are having the acidity of a base. Acidity of a base, we can say that. What I say? Acidity. Opposite. I have said in beginning only. Acidity of a base. What is the acidity of a base? It is the number of hydroxyl ions, a number of OH minus ions produced per molecule of a base. Or what I said you? It is the number of hydroxyl ion or OH minus ions replaced per molecule of a base in its aqueous solution is known as the acidity of a base. Similarly, example is NaOH, it will give you Na plus plus OH minus. So what we will say it is as monoacidic base. So here the acidity is 1. You can see 1. Similarly, calcium hydroxide COH whole twice will give you Ca2 plus plus 2OH minus. What you will say? Diacidic base. The acidity is 2 in this way. Similarly, ALOH whole thrice, even if it is insoluble in water. FeOH whole thrice, even if it is insoluble. It is how much? Triacidic base. The acidity is how much? It is nothing but 3. In this way, this is the definition of basicity or the acidity of a base. Basicity of an acid and the acidity of a base. We can say that. Fine. Next, after that, we will come to that is preparation of acids and bases. So first we will see the preparation of acid. Preparation of acid. We will see first. So acids can be prepared when hydrogen reacts with any non-metals. Alright, like hydrogen reacts with chlorine. Alright, in presence of UV light. That is diffuse sunlight, we can say that, will give you what? 2HCl. Similarly, hydrogen plus iodine will give you what? 2HI. Similarly, hydrogen plus bromine hydrogen plus sulfur. So when hydrogen reacts with any non-metals, when it is heated or when it reacts with any non-metals under UV light or any other conditions, it gives an acid in this way. So in this way you can prepare an acid. As I said you, H2 plus S, when it's heated, it gives you what? H2S, hydrogen sulfide. It is also an acid, we can say that, which gives you a rotten X smell. You must be knowing that, H2S gas. Similarly, another method is when non-metallic oxide reacts with water. Non-metallic oxide means sulfur dioxide when reacts with water, what it will give you? H2SO3. Similarly, when sulfur trioxide reacts with water, it will give you H2SO4. Carbon dioxide reacts with water, it will give you what? Carbonic acid, H2CO3. So this is the second method, when non-metallic oxide reacts with water. Now, the third method is when any salt, for example, NaCl is heated with H2SO4 conc. But you have to heat it below 200 degrees centigrade. It should be below 200, less than 200 centigrade. You will read it, the reason, when you will be studying HCl and HNO3 chapter, you will be reading the reason. Let me tell you now only to you that why I am using below 200 centigrade, why I am heating it. The reason is that below 200 centigrade, NaHSO4 and HCl is produced. What is NaHSO4? Sodium bisulfate. Now sodium bisulfate is not a sticky substance. It's not a sticky substance. It does not stick to the glass apparatus. Point number one. For that reason, we are using below 200 degree. If you use above 200, what will happen? Instead of sodium bisulfate, sodium sulfate will be found. Na2SO4, you will be getting it. And that is a sticky substance which sticks to the glass apparatus and it cannot be removed. You have to throw the apparatus in which you are preparing it. For that reason, we are using below 200. Second reason. When a reaction is being carried out below 200, above 200 if you are taking the temperature, it's a wastage of energy. Alright. The third reason is that at a high temperature, the apparatus may crack. Alright. For that particular purpose, we keep the temperature below 200 degrees centigrade. Similarly, if you take here KCl or if you take here, let us say KNO3 and H2SO4 conc, concentrated sulfuric acid, same condition. What you will be getting it here? You will be getting it nothing but NaHSO4 plus HNO3. So what you find is here is that one thing I will say you that this is a non-volatile acid and these two are the volatile acid. So a non-volatile acid, what it does is that it produces a volatile acid, we can say. From volatile, you cannot produce non-volatile. Remember that. Why? Because volatile means it is going to vaporize. So once it vaporizes, will it get a chance to react with the salt and produce an acid? No. So from a non-volatile acid, you can produce a volatile acid. Alright? Always remember that. From a non-volatile acid, a volatile acid is produced. HCl and HNO3 is volatile acid. So here this will react to give you this possible. It is not at all possible. Alright, it's not at all possible because these two are volatile acid. Before it gets chance to react with it, it volatilizes out. Okay. Now, the next method we can do it is that you can take, that is, let us say a non-metal and you react with an oxidizing agent. Let us say HNO3 conc, concentrated. What it will give you? It will give you H2SO4 plus nitrogen dioxide plus water. In this way, when sulfur reacts with concentrated nitric acid, it gives you sulfuric acid, nitrogen dioxide and water. Again same thing, it is a volatile acid which replaces a non-volatile acid. We can get a non-volatile acid. In this way you can take sulfur here, you can take phosphorus here, you can take it and you can prepare it. So in this way we can prepare acid. Alright. Same way we can prepare also the base. So what are the different methods for the preparation of base? Now in acids I said you, when non-metals reacts with hydrogen, alright, here what will I say? Metals, alright, here what will I say? When metals reacts with oxygen, when it is heated with oxygen, let us say, that is, it will form Na2O, alright, 4Na plus this, it will give 2Na2O, we can say that. So, but this reaction practically it's not possible because sodium is highly explosive, highly inflammable. So if it is heated with air means it catches fire. So it is theoretically possible this reaction, practically it's not possible. You can do with calcium. When calcium is heated with oxygen, it gives you calcium oxide. Magnesium is heated with oxygen, it gives you what? Magnesium oxide. This can be done. Because you know that when magnesium burns in air, it burns with a dazzling white light. That is 2 Mg plus O2 is 2 MgO. It burns with a dazzling white light. So in this way we can do it. This is the first method. The second method we can do it is that is we can take metallic oxide. There we have taken non-metallic oxide in acids. Here we will take metallic oxides. For example, suppose if I take here that is Na2O and react with water, what I am going to get it? I am going to get NaOH, that is sodium hydroxide. Similarly, potassium oxide reacts with water to give you potassium hydroxide. Calcium oxide reacts with water to give calcium hydroxide in this way. Now, the third is that when a salt, for example, sodium chloride, when it reacts with, we can say any, that is your base, or you can take here instead of sodium chloride, you can take here that is nothing but aluminium chloride. That also can be taken because sodium chloride so many times I have taken it. So aluminium chloride when reacts with NaOH, what it will give you? It will give you aluminium hydroxide plus NaCl. It's a PPT, downward arrow. Alright, AlCl3. So 3 NaCl, here 3 NaOH. We can say that. So in this way, when a salt reacts with sodium hydroxide or potassium hydroxide, we are getting the respective, that is precipitates, which is nothing but a base. We can say that, which is a base, basic in nature. This one is. So instead of aluminium chloride, we can also take zinc chloride. We can also take calcium chloride. We can also take lead chloride. So when aluminium chloride or zinc chloride or ferric chloride, we can say reacts with NaOH, we get the corresponding hydroxides. Got it? For example, if I take FeCl3 plus NaOH, what will I get? FeOH whole thrice plus NaCl. How will you know that it's FeOH whole thrice? It gives a reddish brown PPT. Ferric salt always give you reddish brown PPT in this way. So you can prepare it in this particular manner. We can do it. Similarly, the last method is you can heat the nitrates of a salt. For example, if I take lead nitrate PbNO3 whole twice, when it is heated, it gives you what? PbO plus NO2 plus O2. So 2 PbNO3 whole twice will give you 2 PbO plus 4 NO2 plus O2. So you can see the base is produced, lead monoxide. So instead of lead nitrate, you can take here zinc nitrate. You can take here calcium nitrate. You can take here, there is aluminium nitrate. You can take here magnesium nitrate. What it will give you? Suppose if you take magnesium nitrate, it gives magnesium oxide plus hydrogen dioxide and oxygen. We can say that. So one thing you remember it, rather you can write it down also. Potassium nitrate and sodium nitrate on heating, listen carefully, will give you potassium nitrite and oxygen. Potassium and sodium will give you potassium and sodium nitrate on heating will give you nitrite and oxygen. Now after that, calcium to copper, whatever the elements are there, calcium is there, magnesium is there, aluminum is there, iron is there, zinc is there, lead is there. Alright, up to copper on heating will give you, that is oxide plus nitrogen dioxide plus oxygen, as I have written it here you can see. Similarly, if you take mercuric nitrate on heating, it will give you what? Mercury plus nitrogen dioxide plus oxygen. It will not give you oxide, it will give you metal. So in this way we can prepare the bases. Thank you very much.